Good afternoon, everyone. I'm Austin Moeller. I'm the Senior Aerospace and Defense Analyst here at Canaccord Genuity. Today, I'm joined by Bulent Altan, the CEO of Mynaric. Bulent, if you could just give those who aren't familiar an overview on the company and on optical laser technology.
Well, thanks, Austin, and thanks for having me in this conversation. As you've already said, I'm the CEO of Mynaric, and I'd like to give you a little bit of an overview for people who may not be familiar with the company. What Mynaric is, we are a German company. We are producers of optical communications terminals. These are devices that allow you to build networks between satellites, drones, dirigibles, aircraft, ground stations, and other mobility platforms, meaning that you can build wireless networks and connections between these devices. We are a hardware company. We are doing this because we believe that there is a large disruption coming in the whole concept in the way we are communicating, and that aerospace will play a larger and larger role to build A, secure and high bandwidth networks, but also B, in the way we serve the underserved or the unserved around the world. There is about 4 billion people not connected to the internet, to the broadband. And we believe that aerospace can really play a big role there. Also in the whole mobility sector, there could be a much better connectivity solutions. And Mynaric is building these solutions, really backing up those companies, building constellations, building aerospace networks and such with our devices. Austin, I think you're muted. Sorry.
Fantastic. So just to help people understand, what are the key technical and data rate advantages of using free space optical laser as opposed to traditional radio frequency, RF?
Of course. So overall, it's yet another wireless communications system, the optical system. Since the dawn of wireless communication, we've been using radio waves for communication, and they've definitely served us very well. But they have their limitations, as you said, and optical communication is another step forward and a complementary technology to radio that offers a multitude of advantages. I think the main advantage, of course, as you've alluded to, is the bandwidth. Bandwidth today on radio technologies, we are doing some tremendous technology developments to get the bandwidths up to whatever we can do in the gigabits level. But with optical technology, just at the start, at the onset of this technology, we are already seeing 10, 20 gigabits being offered. And today, when you actually work with Mynaric, you're working with terminals that can deliver 100 or 200 gigabits. And actually working with the European Space Agency, we are even working on a terabit solution. So optical communications can really increase the bandwidth of wireless communications between 2 points, multiple orders of magnitude. But there are other advantages as well beyond just bandwidth. Overall, it's amazingly power efficient. If you think about a radio communication between 2 points, the way any communication goes, you start from a point and you just broadcast out in a certain angle towards the other device you want to communicate to, and that power goes into pretty much every direction. You try to concentrate that power to the device that you're trying to connect to, but overall, radios can only do that to a limited extent. What optical does is it really takes the power you want to transmit and really concentrates it towards your communication partner, ensuring that with little power you can achieve tremendous bandwidth. Just to give an example, there are certain satellites today that communicate between satellites via radio waves, and with the same bandwidth today that Mynaric can transmit 100 gigabits, with the same power they can only get a few megabits over. So there is a tremendous increase tremendous decrease in power usage, which is absolutely key in aerospace. The next advantage comes from security. The radio communication, as we talked about, goes in every direction, and it can be detected. This can be detected, and this can be intercepted by anyone who wants to identify and even hack into your networks. When we are talking about contested environments where people don't want you to communicate, or even when you're communicating, want to make actually want to get your within your communication and try to hack it. Radio definitely opens up an Achilles heel there. That in radio communication, that people will be able to find out where you're talking to, because you can set up an antenna and receive, even though you're not the intended partner. And if they're capable, actually hack their way into it. Optical communication, just because of that characteristic, that it goes as a laser beam to the intended partner and nowhere else, is physically undetectable and unhackable beyond just the regular encryption. It is just physically not there. If you're not the intended communication partner, the signal is not coming towards you. So as such, it is of very strategic interest for people who want to be able to talk stealth and in high security, and not be disrupted by others who want to contest your capability to communicate.
Great, that's a great overview there. If we talk about, so Mynaric has developed the Hawk air terminal and the Condor spacecraft terminal. Can you talk about the key differences in design between the Hawk and the Condor, and also talk about what improvements have been made between the Condor Mark III and the Condor Mark II?
Of course. So Hawk and Condor are our two product lines in air and in space, respectively. Optical communication within the atmosphere versus in space have different challenges. Overall, in air, we are not talking about these large distances, these vast distances that we are talking in space. In that sense, that you're talking very often 100, 200 kilometers versus thousands of kilometers that could be the case between two satellites. But there is a different challenge that has to be overcome in air, and that's the atmosphere. If you've ever been to a desert or even just looked over a really hot asphalt on a road, you will see that the actual light, so the image that you see, is flickering. It's actually moving around. That effect in itself is present even in higher levels of altitude. It's just not to that level. But overall, light gets bent in an unpredictable way in air, and one has to account for that, and one has to control and correct for that in these terminals. As such, the Hawk terminals is really made to deal with that level of disruption, or this level of a noise factor. That is a certain amount of difference between the space and the air terminal. The other difference, of course, is that this device has to be outside of the airplane or airship or drone or whatever you have it installed in, and as such, it has to withstand whatever loading and thermal environment that the airplane is going to cause when it's flying at higher speeds. When you look at our space terminal, it's different. It doesn't have to deal, as long as it's not communicating to the ground, and even in that case, for a very short period of its communication, doesn't have to deal with the atmosphere. It is mostly communicating through vacuum that doesn't disrupt the light at all. So in itself, that side of the equation is quite a bit easier. But what the space terminal does is in our Condor Mark III, it has to communicate over 8,000 kilometers. And just to make matters a little bit tougher, it has to overcome that distance. While two satellites do have a certain amount of vibration that really tries to also shake the terminal out of its angle that is going to hit its target, but also it has to do it while both satellites are traveling at 28,000 kilometers an hour. So all of these three things do not make hitting a target the size of a coffee saucer from 8,000 kilometers away with a laser beam quite difficult. So beyond just being able to modulate 100 gigabits or even very soon a terabit onto the laser beam, what Mynaric has to do is develop control systems, hardware that can overcome these vibrations, that can calibrate out and calculate out these types of motions, and still keep that laser beam perfectly centered on the target target.
Thanks. That's a great distinction there. So such an important part of Mynaric's business model is the idea of being able to take optical terminals and scale them to mass production. So just on that point, can you discuss what the government program opportunity is with the Space Development Agency's Transport Layer constellation, as well as your partnership with Northrop Grumman, and how that can feed into other small sat programs like the tracking layer and the deterrence layer, and et cetera?
Yeah. Overall, I think the Space Development Agency is doing a tremendous job being a catalyst to the small satellite and the optical communications industry by having an open marketplace where they are being a top-down architect, of course, of the constellation, but then they leave the innovation to the individual primes and their suppliers. And within that market, they are looking for benefiting from the industrial supply chain that has come with the commercial constellation world. Mynaric, from its inception, has been focused on not just affordability, which we have definitely addressed with our design, but also mass manufacturability. And we have done it from the ground up design, much different than the optical communication terminals that have been offered by other companies in the past. We have really concentrated on a design that is from day one targeting mass manufacturability. One very such development that really is center stage in our capability is our telescope, which is the heart of our terminal. The telescope is a piece that takes that laser light and concentrates it and sends it towards the target terminal. And when you look at satellites, that telescope is subjected to some amazing thermal stress. While you're in low Earth orbit, 16 times a day, you go in and out of sunlight that completely changes the thermal environment. And the telescope has to be a device that across that thermal range needs to be able to really keep its parameters. One could have solved this in many ways. And I think when we were doing one or two terminals, you would probably solve it in a way that does not need to be scalable or even cost effective. But with our material choices, with our machining choices, doing a telescope only in reflective, only out of metal, what Mynaric has done is made a solution from day one that can be easily manufactured, where the machines to manufacture them are readily available and not special made, and as such also is very cost effective. And that is how we have gotten ourselves into the constellation supply chain. What the SDA is doing is exactly building up on companies like that had the foresight to build capabilities as such, and providing them a constellation where they can work. Of course, the SDA chooses the primes, and the primes then choose their suppliers. But I think Mynaric's offering has been very well enjoyed amongst the primes. One such prime, as you alluded, is Northrop Grumman, with whom we have a strategic agreement to supply them with terminals as they need. And although Mynaric is the merchant supplier that is allowed to deliver everyone, of course, with Northrop Grumman, with our agreement, we also enjoy a certain amount of collaboration between the companies, understanding each other's view of the market and opportunities. And that also got us into the Space Development Agency transport layer. And just to round out your question about the rest of the constellations, I think overall, what is going to happen is the Space Development Agency is going to continue being a catalyst, and there's going to be other agencies probably that are going to follow with more and more small satellite constellations. All they will do is look for capabilities around in the market of companies that can produce in mass with little execution risk. Companies that have taken the investment, taken the time to develop the capability to outfit constellations with hundreds, if not thousands of terminals a year, and already have done the production capability to do so. And therefore, I expect that that we will see new entrants here, but the biggest rewards right now going towards the companies like Mynaric, who have already done the investment ahead.
I certainly agree with you there. Just on that point, the most recent news from Northrop Grumman about the successful ground test of a Mynaric terminal for Space Development Agency officials. What can you comment on that, and where does that sort of get us milestone-wise towards getting these terminals up on orbit?
Yeah. As one can imagine, one of the most important things about doing a space mission is testing on the ground. Mynaric has been taking that very seriously. Something that I have grown up in my 2 decades of space business is the fact that the more you test on the ground, the less problems you have in space. And as such, we have done a multitude of different test campaigns and test types in Mynaric. Within the company, we have capabilities to simulate the space environment very closely. And we have been able to show that to our customers, from vibration to rotation to many other different aspects of in-space testing. But there are other aspects to testing as well, which is important that your customer understands how to utilize optical communications, which is still a newer technology. And what we have done with Northrop Grumman is exactly that phased approach into putting 2 terminals in the hands of our customer and doing a test at their facilities. And though it may sound more of a benign test, it is actually two different terminals, from two different variants of our terminal communicating with each other, showing that we have a very interoperable, very capable system, and also showing that our customer interfaces are easily understood, easily integrated, and it doesn't require a very lengthy process to get to being able to deploy our optical communications, but it's easy to just incorporate in any satellite.
Great. Now, currently, the Space Development Agency has selected 3 different vendors to build satellites for them under the first tranche of the constellation. Do you expect that in the future that future tranches may down select to like 2 vendors, and that there's potential to get your terminals onto more satellites being built by other primes? Or what's your thinking about that in the future?
I think the Space Development Agency is doing a fantastic job making sure, as the constellation is growing, that the supply chain is staying engaged. I think they've done a very wise choice in selecting three primes to support the transportation layer, making sure that there is not a single point of failure, but actually three primes that can deliver a third of that segment of the constellation. There are smaller segments of that constellation too, or as they call them, layers, like the transport layer, which I think will go to 2 primes. So it is really a function of the size of the layer that they are competing. But I would say that they would stay with the 3, and they would keep on engaging the whole community rather than doing down selects, such that they always have a large number of suppliers to choose from. That being said, that is the prime side of things. I think overall, as the missions go forward, the primes will look at the supply chain's performance in delivering on time, on cost, on performance. And I think in the supply chain, there will be a certain amount of consolidations. It's not going to be that every prime has to select a completely different supply base. So I think Mynaric's chances could be that as we deliver on time and on schedule and on cost, that we get selected by more primes as a premier supplier of optical comms.
And then in the past, in various presentations, the company has mentioned that Mynaric has been in discussions with a major U.S. aerospace contractor, and that's separate from Northrop. And so can you talk about that in any detail, or the opportunity to use the Hawk on aircraft?
Unfortunately, I can't be naming names here. I think we are still as open about that contract as we have been so far. But what I can say is that the opportunities in air-to-air, air-to-ground, air-to-space communications are vast. there is a tremendous amount of air vehicles being deployed, and they are taking more and more of a center stage also during the current conflict in Ukraine and the role they play, and how important it is that they have strategic, uninterruptible communications wherever you may be, and however well developed your adversaries may be, and how much they try to jam your communications. So as such, I think there is more interest into the programs that we're developing with many different aerospace companies. And as you said, there is one company in northern US, in the US, that we are working with closely in the aerospace sector. I would say testing and repetition and iteration on that program is going well. We are going into incorporating more and more functionalities to see Hawk in many different airframes and drones and whatever, what have you. I think what is going to happen is we're going to see many partners out there with Mynaric that exactly take this core technology and adapt it to multiple different vehicles and do the airframe certification. And that's exactly where Mynaric is very much looking forward to partners like the one that we are working.
Excellent. So just shifting gears here, sort of the main focus for the company this year is around the Condor. What major program milestones are still outstanding for Mynaric this year? Is it mainly OneWeb Gen 2 and Telesat? And can we talk about how many satellites and terminals are planned for these two different constellations and other future milestones we might have?
Yeah. Overall, both Condor and Hawk are definitely our focus of the company. We've been keeping a very focused operation within the company around these two product lines. Condor is definitely making more of the headlines out there as we engage and win business for our space terminal. On the aircraft terminal, we are on the backgrounds more in a hidden way of engaging with aerospace companies to do a bottom-up integration approach. I would say that for Condor, the next steps is, of course, the testing and the qualification of the Condor Mark III, which is slated for this year, as well as the in-space flight of our Condor Mark II terminal on multiple different opportunities that we have. We have contracts to fly it on DARPA. We have an agreement to fly it to the ISS. We have definitely multiple ways to get that terminal into space and gather spacecraft heritage. Actually, this is another place where Mynaric, I think, has been very forward-thinking and in making sure that whatever happens, we have a terminal of our own in space and not just on customer hardware. That's exactly why we're deploying this terminal to the ISS, such that we have a terminal we can do experiments with, we can go into corner cases with, we can try out multiple different things to build up heritage, not just by being on a satellite, but also really pushing that terminal in space to its absolute limits and learn every single thing that can be learned about it. On the business development side in space, I think you alluded to two large customers that are making decisions this year as well. I think Telesat and OneWeb Gen 2 are all doing their decisions. Of course, there is ever-changing situation around the world. I think once again, the Ukraine crisis there definitely put in some roadblocks in some of our customers that have to now plan around that, but I think they're doing that very successfully. I think we could see a certain amount of change in their plans or sharpening of their deployment plans or differences there. But I think Mynaric chances of being placed in either of those programs is very good. But I wouldn't say that they form the only chances for Mynaric. There is multiple new constellations being talked about. For example, there's Rivada networks with a large number of satellites, very comparable to the OneWeb Telesat numbers. There is, of course, in the US still Kuiper, Amazon Kuiper making decisions on how they will go. And then there is a whole multitude of Internet of Things, Earth observation, smaller communication constellations that could and that do form our lead base in business development. So when we round that out, we realize that 2022 is really shaping out to be a spearhead year for us, and it kind of showed that in our numbers. We entered the year with 40 terminals of a backlog, and already in the by the time we actually had our investors update, we were talking about a backlog more than 200, and we hope to keep that momentum, and everything and that we are engaged in today seems to point that way.
Excellent. Definitely sounds like a great pipeline of opportunities there. So my next question is actually from the audience. And so this person was wondering, how does the price point of the Condor and Hawk compare with those of your competitors, whether we talk about like TSAT or Space Micro or Ball? And also, how does the performance of the Condor terminal compare with those competing systems?
I believe we are amazingly cost competitive. We have, as I said, developed some IP that allows us to really not only scale up production, but also keep our costs very low. We are not privy to the cost point of our competitors, but we can only go by soft feedback that we receive from our customers that say Mynaric has always put up a very competitive pricing point, and it is being perceived by our customers as the most, as far as we can tell, as the most price competitive offer. And I think we're doing well, and I think we still have quite a bit of headroom going forward, keeping that price advantage over our competitors while still keeping a very healthy margin on the cost of the terminal.
Awesome. And then just another question from the audience. Can you just clarify, Mynaric is building all the major components of the terminal, right? And what that's generating the infrared laser and the mirror for the telescope and everything. Is that the correct way to think about it?
I would say Mynaric is vertically integrated, but we don't do 100% vertical integration. There is certain places where there is a commodity market to buy hardware from. At the end of the day, some of the pieces of our hardware draws its capabilities from the terrestrial fiber networks. When you're doing 100, 200, 400 gigabits in terra firma, you're using capabilities, especially in the electronics and the photonics, from very established telecom companies that have spent billions of dollars building that kind of capability. We don't replicate that. We actually then buy from the commodity market that really sells that. We do qualify it. We understand it down to the deepest level to make sure it can withstand the space environment. We, for example, do radiation testing and all. But we do work with the supply chain. That being said, I think Mynaric's terminals are the most vertically integrated out in the market. We build our own telescope completely in-house from, I call it billet to telescope, for example. And there is other components within our Mynaric terminals that are vertically integrated that I think are not being vertically integrated in other companies. So I think in that way, we are doing well. And as we produce these terminals and as the numbers go up, as we are seeing right now, we're constantly reevaluating if one or more parts of the supply chain we have passed the threshold where we should be thinking about vertical integration of the next level of hardware.
Great, that's very helpful just to understand the supply chain there. If we think about how building constellations has changed over the past 20 years, I mean, historically, a lot of the constellation sizes that were initially announced were ultimately reduced in size, and they didn't build as many satellites for their constellation as originally planned. So just in the current economic environment, do you have concerns that the scope of a lot of these mega constellations might be reduced in size? And how do you think about that for Mynaric, just in terms of the total number of satellite fleets that are being planned?
I don't see that the numbers will over time settle to be lower. I agree that initial deployment numbers for constellations could be lower than initially thought. But overall, a constellation at a certain point in time ends up building a satellite that is cash flow positive to the company. It's not a cost center. It's a revenue generator for the company, just like any tower is a revenue generator for a mobile operator. And as such, that once that threshold is passed, it is actually in the interest of every operator to deploy more satellites than less. Of course, these satellites are getting more and more capable, but at the end of the day, the business you can do with a constellation is a simple mathematical formula of the amount of bandwidth you can supply per satellite times the number of satellites. And more satellites means more business. And we're going to go into that cycle with any constellation that is successful. And from then on, it's going to be, I think, only limited by the growth of business and the financing capabilities of those companies. But they are all going to want to strive to have more up there, not less.
So I guess the key correlation there is sort of like we've seen in the telecom industry, where there's exponentially more towers being built and the infrastructure is being built out on the ground. We expect to see the same thing mirrored in the space domain.
Absolutely. I think at the end of the day, the way you can look at a satellite in any constellation is a very tall tower. And if at the end of the day, also that satellite is going to have a finite bandwidth. And if you want to deploy more bandwidth or you want to serve more customers in any geography, you're going to have to deploy more satellites.
Perfect. So do you expect that as we see more and more large constellations being built, specifically in LEO and MEO, do you think that most satellites in the future above a certain size will require or will necessitate having an optical terminal to transmit data, just given the spectrum limitations out there?
I would say it is going to be quite a standard hardware to have. I think overall, we're already seeing it with the Space Development Agency that companies and other services around their periphery are thinking about optical communications to be able to communicate with their constellation. There are people thinking about relay services. So overall, it's going to be able to, once you actually install a optical communications terminal to your satellite, you're going to be able to communicate ad hoc with any other satellite that has an optical communications terminal. There's interoperability standards that come all the way from the fiber industry that we are putting into our terminals. We are building a Condor Mark III that's amazingly interoperable and adaptable. So once you put one of our Condor Mark IIIs on your satellite, you'll be able to just choose and say, I want to talk to that satellite. And that level of ad hoc network making is very critical, I think, for the future of the space domain, even in Earth observation, not just in communications constellations. And therefore, I think people are going to adapt more and more these types of these optical communications terminals going forward, and we're going to see a relaxation in all the operational constraints that are put on a satellite that has to live around the ground station locations, limited paths, limited bandwidth, reuse of frequencies and whatnot. And we're going to see more and more all these satellites that are constantly live because they're just the part of a giant mesh network up there, very much similar to the internet down here.
Thanks. Definitely a great explanation there. So I have another question from the audience, and I'll try and ask this as best I can. It's a little long-winded, but can you speak to your involvement in the Unio Consortium and where you see the EC network going? Where are you in that process today? The EC have been giving some lip service to European Union new space companies, but do you think that they'll be serious in moving beyond the traditional European space vendors?
So Mynaric, together with two other companies, then those are Reflex Aerospace for the satellite bus and ESAR Aerospace for launch, and then a long list of supply chain partners has formed Unio, which is our constellation, which we had actually thought about even before the European Commission was thinking about a constellation for European secure connectivity purposes. We had thought about it, and we had been engaged between the three main partners about this constellation for some time, because there is European industrial need for connectivity everywhere, kind of separate from what China and US are building today in constellations. Once the European Commission came up with its idea of a secure connectivity initiative for Europe, we realized that our constellation is a natural match for that work. The use cases are different than the initial use cases that Unio was designed around, but they are very complementary and easy to add. And when we applied to the European Commission's new space study, we were one of the 2 companies that were awarded that study. We are still in that study phase on how that constellation would look like. We are in constant exchange with the European Commission. And I have to say they have been mostly open about the way we do these things. But I also have to say it is new territory for them as well. And they have to realize that certain things need to adapt to a commercial service provider rather than a public-private partnership type of operation where the European Commission just wants to buy the satellites and operate the service on their own. We, as Mynaric and the rest of the consortium members, we believe in a commercial service that also can serve the European Union's needs, and we believe that Constellation should stay commercial. And that's most of the focus of our conversation that we are having with them, making them comfortable with a concept like that, and also showing that the use cases that they are looking for is more than enough to design a constellation. They don't have to do a top-down design of the rest of it. And let's see how their comfort level comes in. We are remaining hopeful, but of course this will be a big step for the European space industry in changing the way they operate. So far, they haven't done these types of changes that we have seen in the US, like commercial orbital transportation services or the cargo resupply services, or even commercial crew. They need, I think Europe still needs to take that step of doing government as an anchor customer of well-defined services. That's still a step to be taken.
Definitely very interesting insights there on European space commercialization and with government services. Just a follow-up to that question, do you know if the constellation is going to be KU or KA band? And do you have any idea what the timeline might be around them moving forward with decisions on network implementation?
The way we are looking at the constellation, and I think this is really up to each one of the constellations, we are going to have to use multiple different frequencies, and we actually start even lower than KA-KU because there are certain use cases that require much different bandwidth and much different end user experience than just the broadband constellations do. So the way we are designing our satellites, there is going to be a multitude of frequency bands that are native to that constellation, and we are even looking into the higher bands as well because we know that we can't just stay in KU and KA and be future-proof, especially given the fact that we are still a few years away from the satellites being deployed. So we are experimentally including the higher bands like QV and W in these satellites, and then doing some amount of, with our Gen 1, our plan is to do certain amount of technology demonstration that then can go into use in the later generations in operational use.
Excellent. Thanks for all the info there on that constellation. Can you talk about the facility that is in Munich that's being built out? How many employees have you currently hired to mass produce terminals there? And just in light of the constraints on the labor market, how many do you view are still needed?
Actually, Mynaric has been going through a tremendous growth spurt over the last 2 years. This year, we already passed the 300 employee mark. If you think about it, about less than 3.5 years ago, when I entered the company, we were less than 60 people. So that's a very healthy growth. And when you look within the company where that growth has been, it has been really in the areas that the company needed to grow to be able to produce many terminals a year. Production from top down has been increased in capacity, and we have been able to hire quite a bit of people. Engineering, of course, has been increased as well as we do more in detail engineering to make sure it is, our terminal is even so minutely designed that it can be done with a workforce that is brought from outside, that it may not have space or optics knowledge, but is a blue collar workforce that is to be trained, and it can be done quickly. So growth has been not hindered by the current environment, and it hasn't been in the last 2 years. We've been able to grow quite well, and I gotta say, there is definitely quite a willing workforce in Germany, because also of the current move towards electrification of the automotive market, that is looking for a new home and has been finding a home in the aerospace, especially the space market, and we've been able to employ those people.
Fantastic. Glad to hear that the build out of the employee roster has been going well. If we think about the constellation or the terminals for the applications of both air to space as well as space to ground, can you talk about where that's currently at and what some of the advantages and challenges are around that in terms of weather relative to RF?
Yeah. So when it comes to space to ground, as I said earlier, we have a Condor Mark III that is amazingly adaptable. You don't have to buy a different Condor Mark III if you want to do space to ground, than the one you would buy for a space-to-space communication. Condor Mark III, you put on your satellite, can talk space to space, LEO to LEO, LEO to MEO. And if you want to ever talk to the ground, it can also talk space to ground. It just switches to a new protocol inside that can deal with the atmospheric effects. That being said, as I said, optical is a complementary capability to radio frequency communication, and lasers still, these optical signals can still not go through very thick clouds, such that if a ground station was to be covered by a thick ground layer, we would have to fall back to radio communication at that time. That is just one property of optical communications, but most of the customers that we have today that do space to ground communication in optical, the way they overcome that is they build a mesh network that can route the data anywhere they want to, and then they talk to ground station that does not have a cloud over it. They just kind of reroute the data. And ground stations today very often are built around places that have historically very little cloud coverage. So it's not an end-all be-all. You can't do optical communication to the ground everywhere all the time. For that, RF is more resilient to go through the clouds. It still, of course, takes a hit, but it's not as outcome is not so binary. But optical plays a big role when you want to do point-to-point space to ground whenever you want to really do very high bandwidth.
Excellent. If we think about the company in terms of cash burn and capex and capital needs over the next 12 months, as you're progressively scaling production of terminals to meet some of these new programs, do you feel good about Mynaric's cash balance and capital right now, or do you think that there may be a need sometime in the next 12 months to address that?
So the way I see 2022 and 2023 is these are very important years in the optical communications market. A lot of constellations are making their decision. There's a lot of terminals to be delivered. New use cases are being opened up. Really, the business is booming today. The years that we have been getting ready for have finally arrived, and we are playing a big part in it. I would not like Mynaric to miss the opportunity. And as such, we are always looking into having enough cash reserves within the company to execute any new vision or any additional burden or work that may come on us. And because of that, we also keep multiple options open. We are always ready to bring in more cash into the company as vectors change for us. And they may be raises, as you mentioned, but they also maybe debt vehicles or other non-dilutive measures. So we keep all of those options open. I don't want to say no to any of them because the opportunity is too large right now to be penny wise, pound foolish. I think we have just closed one such debt vehicle to get the company additional means, and we will always explore those first. There is a very good view from the European governments that space is very important, and as such, they are also looking into establishing debt vehicles in Europe for companies such as ours. And there is other ones out there as well. We will be looking at them, but we will never also say no to a raise. If there is the opportunities out there, we want to be able to stay nimble on our feet.
Excellent. So just one last question here, and this is from the audience. Can you discuss what the timeline and scope of the Unio constellation is to the degree to which you have knowledge?
I will say a little bit about it. I think it's for the consortium and the final Unio consortium to really roll out the full plan. But currently, we are in the study phase. The study phase will close out here very shortly, and then there is going to be a review phase by the European Commission for the case of covering the European Commission's use cases. That being said, whichever way the European Commission decides, there is still the industrial solutions and the industrial services and the B2B solutions that we want to offer to many of the players in Europe. So we will keep on doing Unio. The way we are looking at it is that we want to be hardware first and get to prototypes very quickly. If we can, we want to deploy satellites already in next year and build up from there, quick successive iterations of demo missions. And then we're looking for the deployment of one of the orbits starting in about 2 to 3 years from now.
Excellent. And actually, just since you were one of the first employees at SpaceX, I was wondering if you have any quick story you could tell about your time at SpaceX. What was one of the most interesting things that happened, or an interesting conversation that you had with Elon during your time at SpaceX?
I don't want to go into the anecdotes right now, but maybe the way I would say it is, I think there's a lot that I got to experience there. I was there in 2004 when we were just a 40-person shop. It was quite an exciting time for any young engineer to go in there and learn a lot about the space industry. Overall, we did the same. Learn quick, iterate fast, be hardware first. Approach to hardware development, and I got to be there on console for the first time we did orbit, for the first time we made it to the ISS, for many of the first that we did as a company, and I think we're doing quite well in incorporating the lessons learned of that experience into Mynaric as well. There is a sizable number of people who've chosen the same career path after their SpaceX career over in Mynaric, and we're building exactly the same mentality of do quick, fail quickly, and find the right path to the correct solution. And we all have our anecdotes in the back of our heads, but I think that's a story for another time, maybe individually over beers.
All right. Well, thank you so much, Bulent, for taking the time to come on today and talk about Mynaric and talk about the opportunities for optical laser terminals. Thank you so much. I appreciate it.
Thank you very much, Austin, and everyone who dialed in. It was great to talk about Mynaric.